Okay, let's talk about the problem 1. And now we know the density function of x and y. So fx equals to ux minus 1 minus ux minus 2. And fy equals uy minus uy minus 1. And now we can calculate in two methods. And the first method, we can use convolution method. So for the convolution method, we know that fc equals fx convolute fy equals to from negative infinity to positive infinity, fx alpha multiply fy z minus alpha. Oh, sorry. Here is z. fxz convolute fyz. So that equals from negative infinity to positive infinity u alpha minus 1 minus u alpha minus 2. This is the fx. So we multiply u z minus alpha minus u z minus alpha minus 1 d alpha. And this part is fyy. And now we calculate this form. It equals from negative infinity to positive infinity u alpha minus 1 multiply u z minus alpha is this one, multiply this one, and minus u alpha minus 2 multiply u z minus alpha, and this one multiply this one, and minus u alpha minus 1 multiply u z minus alpha minus 1, and it's this one and this one. And last, we should use this, multiply this. That's plus u alpha minus 2 multiply u z minus alpha minus 1, and the alpha. So we can calculate it partially, and for this part it equals 1 to z u alpha minus 1 u z minus alpha, and we also need to multiply u z minus 2, and for this part is from 2 to z. It equals alpha minus 2 u z minus alpha, we also need to multiply u z minus 2 the alpha. Oh, sorry. This is z minus 1, z minus 2 the alpha. Okay, and this part is minus z 1 from z minus 1. So it is u alpha minus 1 u z minus alpha minus 1 multiply u z minus 1 the alpha, and we plus from this part is from 2 to z minus 1. It's u alpha minus 1 u z minus alpha minus 1 to we also need to multiply u z minus 2 the alpha. So we can calculate all of them, and we can get the answer is equals z minus 1 multiply u z minus 1 minus 2 times z minus 2 times u z minus 2, and plus z minus 3 times u z minus 3. And this is the answer for the question 1. And for question 2, we can use geometric method. So for geometric method, we can get that the graph of fx is this from 1 to 2, right? And this is 1. And for y, fyy is like this. And if we want to use geometric method, we should to shift the graph of fx. So shift it on the left from 1 to 2 to 0 to 1. So now we can use this and this to calculate the density function of z. So if if the z, we can see the z has two situation. This is 1 and this is 2. For situation 1, z is less than 1. So we can see this part is we must to calculate this part. It's f z equals this point is z, 0 z. So this area is 1/2 times z equals to z to the power 2/2. So this is the distribution function. So the density function is is Z. And for the situation 2, when Z more than 1 less than 2, it's like this, and this point is Z. This point is Z, and the area we should calculate is like this. We can use the big triangle. This is a big triangle to this big triangle minus the two small triangle. So for the big triangle, it's this point is Z0, so it's Z to the power 2 over 2. And this triangle is the same as this triangle, so this area is Z minus 1 to the power 2 over 2. And we should multiply 2 because there are two small triangles. So that equals minus Z to the power 2 over 2 plus 2Z minus 1. So the density function is minus Z plus 2. And there are situation 3. The situation 3 is like this. This is situation 3. So for situation 3 is Z more than 2. If Z more than 2, we know that the distribution function equals 1, and obviously the density function equals to 0. So above all, we can draw the graph of the density function. It should like this. But we shift the x to the left, so now we should return the FC to the right. So the original graph is like this, from 1 to 3. And this is the graph of FC.